Recording. Okay, class. I hope all of you had a wonderful break yesterday with the Labor Day break. Today we're supposed to cover, or this week, we're supposed to cover sections 1.5 and 1.6, and we will be going over that today. So before I do that, did any of you have any questions?
So I have a question. Are the videos that are on MyLab the only videos that we have for the worksheets? Because they weren't very informative and I was honestly confused.
Okay, you're talking about the last video?
Um, well, so I saw like your email saying to go to MyLab to watch your videos, but the only videos that I could find were the ones where like the textbooks were. Are those the wrong ones?
Yes, what I'm going to do, I'm going to send you out the link because I changed
Okay.
the worksheets up. So the worksheets that are like due this week, they're directly from the textbook, but I will be going over them in class today, and there will be video for it as well because I'll be recording it as well. So
Okay, thank you.
yes, okay, no problem. Oh, and by the way, the videos that you're supposed to watch from the My Math Lab, that is to prepare you for the upcoming assignment. That's not supposed to necessarily review the worksheets, but it's supposed to be prepare you to get ready to do the worksheet. Okay, you follow that? Okay. All right. Now, how was the Desmos projects for you all? Now, as you all are typing into the chat, I want to say with the Desmos projects, a lot of you did quite well with them. Some of some of you didn't do them at all, but I made a few comments about some small little errors that some of you made with the Desmos project, which I'm going to cover today to let you all see what some of those errors were, so you won't make those errors again. So let me pull up Desmos, and then I can discuss that with you all. Let me see, where it is. Here we go. All right, let me share the screen here. Okay, now a couple errors. Like one thing, you all were supposed to create folders and then have the items in the folder. Some of you created folders but did not have the items inside the folder. So let me go over that. So you'll click on add item, you'll go to folder, and let's just do folder one. Then you're supposed to hit enter. Now again, how this line is going down here, that lets you know that whatever you type here will be inside of this folder. So let's say you had 5 plus 3. That's one thing. Press enter. Say you had x equals 12. Press enter again. As you see, it keeps expanding. And then say you had y equals 3. Okay, now let's say you're done with this folder. You will click on the next line, and that breaks the chain of the folder. And to let you know that all this is in that folder, you will click this arrow, and as you see, it all disappeared inside of that folder. And then here you will create, your next folder. All right, that was one thing. Another thing that was an issue with some of you was the exponent portion. You didn't know how to properly put an exponent on your value. So let's say we had 2 to the power of 3. You could hit 2, there's a to the b power here. You could hit this, and then 3. That's how you would do an exponent. Now we also had some of you all, I don't know if this was just a mistake or what, but we had a problem like 3 times the square root of 100. So to type that in your calculator, you'll hit 3 square root 100. And then in order to get from under this 100, you'll press the right arrow key. And let's say you have plus the square root of 144. Okay, this is how you would set those radicals up. When it's multiplied, it's a number outside of the radical times the radical. All right, so, oh, and one other thing that I almost forgot about, pi. A few of you use 3.14 for pi. 3.14 does not equal to pi. 3.14 is an approximation for pi. But if you notice here, we have a pi key on this keyboard here. So whenever you have anything with pi, unless the directions tell you otherwise, you're to use this pi key here. Now, if the directions tell you that pi equals 3.14, you will use the 3.14. But if it doesn't tell you that, it's assumed that you're going to hit this pi key. So if you hit pi times 5, now this is what pi times 5 is. But let's see if we did 3.14 times 5. There's a big difference. See all them extra numbers we have here? And there is a slight difference. So I think those were the primary mistakes that I saw when it came to the Desmos. It wasn't anything major, but those were some of the errors on the Desmos project. Now, another question. Did you all have any questions about anything? Oh, and by the way, I did send out an email to a few of you all that I had a certain way that I wanted you all to email me. And some of you were doing it and some of you were not doing it. So I sent out the emails to the students that were not emailing me the way how I prefer to be emailed. It was a short video, less than a minute. And so everyone that was not emailing me correctly got that email. So okay, with that being said, I want to go on and I want you all to go to do the worksheets for today. The worksheets for today will be under week 2. And then you have 1.5 to 1.6 learn and check. And then here's the worksheet. You'll click on here. Then the worksheet will come up. Let me just open up this file. All right, now with this worksheet here, if you notice here, this comes directly out of the book. These are how our worksheets are going to look like from now on until all of you get the textbook. Now, I saw from the bookstore today that they supposed to send you all out an email, and they actually were supposed to mail out the textbooks to you all. So they should be coming very soon. I would think probably by the end of this week. So be on the lookout for the textbook, because once the textbook comes, there aren't going to be any worksheets on JetNet anymore. It's just going to be strictly out of the textbook that we will be working on in class. All right, so I did tell you all in the last class that I would be uploading this worksheet. and that you all needed to download it to start working on it. So we're going to work on it today, and I'm going to break you all up into the breakout rooms. And then what I'm going to do after I break the breakout rooms. Oh, somebody's
I have a question before class starts. I'm sorry.
okay.
I have a question before class starts. I tried to upload my learning checks. I had the Cam Scanner app, and it prompted me to pay for a trial. And I wanted to know if anybody else had that problem, or am I downloading the wrong app? Because I had to email you, the learning checks.
Okay.
That pops up for me too, but it lets me X out of it.
Yeah,
Okay, so you just skip it?
yeah, you may have to just
Yeah,
X
I think
out.
it's
There's
some
either
premium.
an X button there or a cancel button or something there that you can click on if you're just interested in using the
Okay.
free version.
Okay, because when I tried to proceed, it was prompting me to purchase, and I couldn't cancel it. But I'm gonna try again. I just wanted to know if anybody else had that issue.
Well, you know what you could do? Are you by a camera?
Mhm.
Okay, so this is what I'm going to do. When I send everyone else to their breakout rooms, I have you share your screen with me so we can go over that and see if we can get down to this real quick. Okay. It
Okay.
should only take a couple minutes. So let's get this problem. Okay, so did anyone else have any questions? All right, so let me put you all in the breakout rooms. All right, you all can go right to your breakout rooms. Rian, you need to go to your breakout room. Okay, class, we just finished our breakout sessions. So now we're about to go over the worksheet. Okay, now I showed you where to get the worksheets from. So now let's get started here. Now this is on page 43, and again, when you all get your textbooks, you all will be able to, actually this is page 42. You will be able to see this a lot clearer with your textbooks. But it says you are a technician at the local power plant, and you have been asked to prepare a report that compares the output and efficiency of the 6 generators in your sector. Each generator has a graph that shows output of the generator as a function of time over the previous week, Monday through Sunday. You take all the paperwork home for the night. Your supervisor wants this report on his desk at 7 a.m. And to your dismay, the cat scatters your pile of papers out of the neat order in which you left them. Unfortunately, the graphs for generators A through F were not labeled. You will know better next time. You recall some information and find evidence elsewhere for the following facts. General generators A and D were the only ones that maintained a fairly steady output. Now, if you look here for generators A and D, that would have to be a toss up between 1 and 3. They are the only ones that have a somewhat steady output. Do you all agree with that?
Yes.
Okay. Now we need a little bit more information in order to distinguish between A and D. Now, the only other place where they talk about A or D is that last bullet point. It says generator D was the most productive one over the entire week. So we know that we narrow A and D down to graphs 1 and 3. And all we have to do is pick the one that's the highest, which would be 3. So generator D would be 3. So what I'm going to do, I'm going to write down the numbers of the generators. And then so 3 would be D. So that means 1 would have to be A. So we took care of A and D. Now it says here, generator B was shut down for a little more than 2 days during midweek. Okay, it says here that generator B was shut down. So if something is shut down, that means it has no output, right? Is there any one of these that has absolutely no output somewhere in the graph?
Yeah, that would be 2.
2. Yep, so 2 would have to be B because this has absolutely no output. It was shut down and it shows that about in the middle of the week. Okay, so far we got A, B, and D. Now we're just missing C, E, and F. Okay, generator C experienced a slow decrease in output during the entire week. Okay. Now, if you look at these last 3, which one seems to show a slow decrease in output during the entire week?
All right, so I think that would be 4 because that goes like slower, like it has a slower rate over the week. See, now I had confusion because I didn't read this correctly because I thought D was asking for another. I thought the last bullet point was asking for the most productive over the entire week. I didn't realize that it was also generator D, so I had a mix-up. So I had to go over some things because I completely forgot about F while I was working through this.
Oh, okay. So we see here 4 would be C. That's the one that's going down the slope. So if we look here on the next bullet point, it says on Tuesday morning, there was a problem with generator E that was corrected in a few hours. Okay, it says on Tuesday morning, there was a problem with generator E that was corrected in a few hours. Now, typically when there's a problem, typically there's a significant dip in production. It's not necessarily a shutdown, but it's a significant decrease in production. Which one of those looked like it was a significant decrease in production earlier in the week?
5.
It would have to be 5 because they specifically told you that this happened on Tuesday. And remember, earlier in our directions, it says Monday through Sunday. So that means that Tuesday will have to be a little earlier in the week. So that would have disqualified 6. So this would have to be 5. And then finally, the only one that's left is F. So those are all of your generators. Does everyone follow that? Okay.
Yes.
All right, now it says in exercise 2 and 3, identify. Let me scroll down here. Exercises 2 and 3, identify the independent variable and the dependent variable. Then interpret the situation being represented. Indicate whether the graph rises, falls, or is constant, and whether the graph reaches either a minimum smallest or a maximum largest output value. Okay, let me expand this a little bit here because I want to play around here with the pen. Let me do here with the yellow. All right. It says here, time required to complete a task in relation to number of times the task is attempted. Now, we're looking here for the independent variable. Now listen, when we look at this graph here, the horizontal line is the x-axis. The vertical line is the y-axis. So we know, according to what we know in regards to graphs, that the x-axis always is the independent and the y-axis is always dependent. So here, this would be the number of attempts. I'm just going to put N for number of attempts because I'm not good at writing with this pen here. Okay, dependent would be the time. So we'll put time. Okay, so that's the independent is the number of attempts. The dependent is the time in seconds. Now, the interpretation. If you look here, just looking at this graph here, you notice that with the number of attempts, because we don't know exactly what the time is here because the time is not really labeled. It does tell you that it's in seconds, but down here on the y-axis, we don't know how many seconds it is. But what we can tell is this here, the number of attempts. If you notice here, we have attempts 1 through 6. And if you notice, as we go higher with the attempts, it looks as though that it's taking us less time. So basically, this is telling us that the time required to complete the task decreases with the number of attempts, or as the number of attempts increases. So time decreases as the number of attempts increases, just to summarize that up. Does everyone follow that?
Yes.
Okay. All right. Now that's one interpretation. You can have more than one interpretation. You could say as a person attempts the task more times, the task takes less time to complete. After 5 attempts, no further improvement is made. You can make those observations as well. Okay, now we go down here to number 3. The number of units sold in relation to selling price. Okay, now the independent variable, which one is it?
Selling price.
The selling price. And the dependent is the units sold. Okay, now the interpretation. Now watch this. It's not as cut and dry as this first graph is, because we see the top value is here and it's just going basically steady down. Here, this goes up and then it starts to go down. So we have to account for that in our interpretation. Now, what you could say as far as the units sold are it's stated here. Initially, as the price went up, as the selling price went up initially, the units sold went up. But as the selling price kept increasing, after it got to its maximum point, then it started decreasing until it got to none sold. That's just like, take for instance, just using this, take a pair of Nike gym shoes. Now, if they come out with a pair of Nike gym shoes that's like $20, a lot of people are not going to buy them because they're $20. But if they raise the price up to, say, about $80 or $90, you will see a spike in the sales. But then as they keep increasing the price will go down. Because if they came out with $1,000 pair of Nike shoes, not many people would be able to pay $1,000 for a pair of shoes. Do you all follow that?
Yes.
Okay. All right. So now we go to problems 4 and 5. This is still on page 43, but for some reason, when I was copying and pasting this, it skipped over to the next page. So these are the last two problems from 1-5. It says here, exercises 4 and 5, sketch a graph that represents the situation. Be sure to label your axes. The sale price of a computer is a function of the percent of discount. Now we have to determine which one of these would be on the x-axis and which would be on the y-axis, which would be independent, which would be dependent. Now, when you see here, when you see a function of or is a function of, typically whatever is behind the is a function of is your independent variable. So percent of decrease, I'm just going to put a P here, or percent of discount. Just going to put a P here. That'll be your x-axis or your independent variable. And then the sale price of the computer, I'll put the S. Not really good at the sideways S. And that would be your dependent variable. Okay, does everyone follow that? All right, now, the sale price of a computer is a function of the percent of discount. Okay, so here's the thing here. This is the percent of discount. This is the sale price. We know when the X and Y axis meet, that's typically your 0 point. It's 0 for the sale, 0 for the percent discount. I'm just saying for that point. Okay, now, if there's no discount, what percent would you be paying for the merchandise?
Full price.
You'll pay full price, which is 100%. And typically, the price that's on the tag is the highest that you will pay for it. So when your percent of discount is at 0, your sale price should be at its highest point. Let me use another color. Let me use something. Let me use purple. Okay, it should be at its highest point. That should be your selling price. As the percent discount keeps increasing, then your sale price should go down. So you're fortunate enough to get like a 90, 95% sale, to keep going down. Does everyone follow that? All right.
Yes.
Thank you. Okay, number 5. It says the area of a square is a function of the length of one side of the square. So now, it says it's a function of the length of one side of a square. So this would be the side. Wow, almost made it. Yeah, that doesn't look. So I just leave it as an S. Okay, so that'll be the side. And then now, over here, we will have the area. So we'll put the A here. So that'll be the area of the side. So we have the side here, or basically it's the length of the side, and then also the area. Okay, now, when you're dealing with area, what are the units in? Like, what is the measurement of the units?
Square feet.
Yes, there's square feet, square inches, square yards, they're square units. So now, whenever you graph something that's in square units, it's going to be representative of a parabola. And parabolas typically look somewhat like this, like almost a U or upside down U. Now, when you're dealing with a shape, there's a little uniqueness about the shape. There are no negative values for a shape. You can have 0, but you cannot have a negative value. So what you would have here is you would have like half of a parabola. Now they tell us the area of a square is a function of the length of one side of a square. So basically, if you notice, the area is going to increase faster than the side of the length of the side, because whatever the length of the side is, you're going to multiply that value by itself. So if the side is 3, you would take 3 times 3, and that would be the area. If the side is 9, you would take 9 times 9, and that would be the area. So basically here, if this was 9, you see how much higher this is up here? That's because it's going to be multiplied by itself. Does everyone follow that? So these are some representations of the graph. Now, we move on to the 1/6. Now, 1/6, I did not put the page number here, which I should have. See if I can find the page number. The page number was 55. The page number, and I'll just write that here. The page number was 55. That was the page number that this came from in your textbook. Okay, now it says the following table of data from the U.S. Bureau of the Census gives the median age of an American man at the time of his first marriage. And as you see here, at first, it was going down. It was going down up until the 60s. Now, once we got to the 70s, it started back increasing. And it's almost 30 years old, in 2015. It says now, use the data to answer exercises 1 through 6. It says determine the average rate of change in median age per year from 1950 to 2010. Okay? So this is what I would do. 1950, I'm going to go off to the side here. 1950 is the year. So we had 1950. And the age is 22.8. Yeah, I'm going to have to get a stylus pen for this. I think this would work a lot better. So we had, matter of fact, let me do this here. Yeah, I think I'll do it like this. Okay. So we were at 1950, and it'll be 22.8. All right, and then we would do 2010, and it would be 28.2. Now they asked us here to determine the average rate of change in median age per year from 1950 to 2010. So what we would have here is, we would have, this would be our X value, this would be our Y value. This would be our X value, this would be our Y value. This would be X in the first ordered pair, Y in the first ordered pair. X in the second ordered pair, and Y in the second ordered pair. So our average rate of change is really the slope. The slope is the rate of change. And as we know, the slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now we go through and substitute. Y sub 2 is 28.2 minus y sub 1, which is 22.8, divided by x sub 2 is 2010, and x sub 1 is 1950. So we will have 5.4 divided by 60. When you put this in your calculator, it'll be 0.09. So it'll be 0.09 years of age per year. So that's the average rate of change. It goes up 0.09 years of age per every year. So we're basically just finding the slope, but they just describe it as a rate of change. Now it says describe what the average rate of change in Part A represents in this situation. Basically, the average age of a man at the time of his first marriage is increasing by 0.09 years of age per year. So that's basically what it means. All right. Now we go here to number 2. Now number 2, it says determine the average rate of change in median age per year from 1930 to 1960. So we go here to number 2. Now we look here at 1930, we had 1930 and we had 24.3. And then 1960, we had 22.8. So again, we have x1, y sub 1, x sub 2, y sub 2. And then we go through and do our slope. Now we know y sub 2 goes first, minus y sub 1, all over x sub 2, minus x sub 1. So our denominator would be 30. Our numerator would be a negative 1.5. Now, if you put this in your calculator, you will get negative 0.05. And I'll write this down here. So it'd be a negative 0.05 years of age per year. Now, number 3, it says, what is the average rate of change over the 95-year period described in the table? So basically, they already tell you that it's a 95-year period. So watch this. They actually helped us with half of the problem. So 3. We know our slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. They already told us that x is the difference in our years. We already been told there's been a difference of 95 years here. So now, if we look here as far as the years, that'll be 1920 to 2015. So we look here at their values. We know the 2015 at 29.2 would be your y sub 2, and your y sub 1 would be that 24.6. Now when we subtract that, that would give us, what's that, 4.6? 4.6 over 95. And if we round to 3 decimal places, it'll be 0.048 years of age per year. Okay, now before we go to problems 4 and 5, were there any questions over anything that's been covered here? Okay. Okay, number 4. It says, during what 10-year period did the average age increase the most? Now we can look here. If you look at all of these, 1970 to 1980, it went up like 1.5. All the rest of them was less than a 1.5 increase. So it'd be 19 from 1970 to 1980. Now, that went up. Now we have to write down how much it is as far as years of age per year. So it's from 1970 to 1980 that the age increase was the highest. The rate of change is, so we got to figure that out. So it's from 1970 to 1980. So if we look back up here, 1980 would be our y sub 2. Well, let me write it out. You had 1980, which is, okay. You had 1970, and you had 23.2. You had 1980, and it would be 24.7. So when we're doing our slope, our y sub 2 is 24.7. Our y sub 1 is 23.2 divided by x sub 2 minus x sub 1. So 10 would be our denominator. And we subtract here. Like I said, it was 1.5. We take 1.5 divided by 10. That would give us 0.15. So the rate of change is 0.15 years of age per year. So it went up 0.15 years of age per year. All right. Number 5A. Now I think number 5, if I'm not mistaken, you have an A, B, and a C. Okay. It says, what does it mean in this situation if the average rate of change is negative? Okay. Basically, it means the median age of a man at the time of his first marriage is decreasing. So that would mean that the man is getting married at even a younger age. All right, so we go to 5B. It says determine at least one 10-year period when the average rate of change is negative. So if we go back here, it just says determine one of them. So that just means that it's decreasing. So basically we could go 1920 to 1930. That's one 10-year period. And then we could do 1940 to 1950. And I don't know if that's the last time where it decreased. Yeah, I think that was the last time that it had it decrease. So you could pick either one of those. So let's take a look at C. It says, what trend would you observe in the graph of medium age if the average rate of change were negative? That is, would the graph rise, fall, or remain horizontal? So remember, if our value is negative, remember that means for the rate of change, that means that your slope would be negative. And we know if we have a negative slope, the graph falls to the right. So we know with a negative slope, the graph falls to the right. All right. So now we go here to problem number 6. 6A, B, and C, and that would be it for this exercise. Okay, 6A, is the average rate of change 0 over any 10-year period? If so, when? So basically that's when it stayed the same. It'll be 1930 to 1940, and then 1950 to 1960. Yep, those are the two periods that you could choose from. Okay, B. What does a rate of change of 0 mean in this situation? Basically, it means that the median age of a man's first marriage stayed the same. That's all it means, that it stayed the same. Or if you want to use another term, you could just say it stayed constant. Okay, C. What trend would you observe in the graph during this period? That is, would the graph rise, fall, or remain horizontal? Okay, we know if the slope is 0, the graph would be horizontal. And that is basically it for the worksheets. Now, what I would need for you all to do for the next class, let's take a look here. Let me go back here. Now, I know we are on week 2, but when this was designed thinking that we met on Monday, Wednesday. So we're actually going to have to go into week 3 for one of the assignments here. So I would want you to look at 1-7 and 1-8 as far as the material. Look at those videos, get the notes, and then come to class ready to do some work. Now, do not, and I repeat, do not download the worksheet for 1-7 or 1-8 until tomorrow, because I have to upload the worksheet for 1-7 and 1-8. So remember, you'll watch the videos for 1-7 and 1-8, and then you will download the worksheet tomorrow. The only check assignment that will be due this week is only 1-5 and 1-6, which we actually covered today. That is the only one that's due this week. And just to clarify this is actually due Friday by 11:59 p.m. I think I'm going to change that since we went over 1-5 and 1-6 today. Yes, I think I'm going to change that, and I'm going to make this, I think I'll make this due, no, I'll leave it Friday. So that will still be due Friday. And remember, from week 1, you still have Desmos Tech Project 2, which I believe is due tomorrow. Yes, it's due tomorrow. And I'm not sure, I think Project 3 is also due tomorrow. Let me just be sure. Yes. Projects 2 and 3 from Desmo is due tomorrow by midnight. So make sure you get those in. And if you have any questions, you can email me. And I will be sending out an email tonight of this video. So you all will have access. And for those of you that were not here, you will have the access as well. All right. Have a wonderful evening.